Hello, my name is Kathy, and today I am going to solve the swimming pool problem. Now, this problem is labeled as a physics problem, but to be honest, this problem could come up in either a physics or a chemistry course. So let's get started. I am going to share my screen because I prefer to use my iPad. So let's go. So we are told that we have a swimming pool. So I'm going to go ahead and draw my swimming pool and represent it as a box. And we are told that our swimming pool has a length of 10 meters, a width of 4 meters, and a depth of 1.5 meters. We are also told that our pool starts pretty chilly with a temperature of 16 degrees C. And what we want to know is how much heat is needed. So let me write the question. How much heat is needed to raise the temperature of the pool to 32 degrees C. So let's make our pool nice and warm. Okay, so how much heat is needed? Well, key word there is heat, right? So whenever I see the word heat, I am thinking of little q, the Q equation. The Q equation helps me figure out how much energy or heat I'm going to be adding to raise the temperature of something, of a substance. So let's go ahead and write that equation out so we can see it. So that is Q is m, the mass, times C, the specific heat, times the change in temperature. So to solve this problem, we need the mass of water. Well, we're told that we fill the pool up all the way to the top. So right now, we don't have mass, but we have volume. So we'll come back to that in just a minute. C is the specific heat, and it would be the specific heat of the substance, which is water. Now, this is something that you can look up. I just happen to have this memorized. It's 4.18 joules per grams degrees C. Now, what this tells me is that I'm going to need to have my mass in grams and my temperature in degrees Celsius. And finally, the change in temperature, which we can see we have an initial temperature and a final temperature. So that one's the easiest of the three. Let's go ahead and go back to the mass. So we need the mass of water, but we have the volume. Well, wait a minute. We also know it's water. And water has a really simple density, right? So the density of water is something that you can also look up, but many of you probably have this as well in your head. It's 1 gram per cubic centimeter. Now, however, we have meters, so it might be more helpful to convert this unit to meters. So I'm going to do that. So the density of water is 1,000 kilograms per meters cubed. All right, so now we can use this density because we're going to have our volume in cubic meters. Okay, so let's go ahead and let's find our volume and then use it to find our density. So volume of a cube is just going to be length times width times height. So I'm going to go ahead and plug in 10 meters times 4 meters times 1.5 meters, and that's going to give me 60 cubic meters. I don't want volume, I want mass. So I have density is mass over volume. Do my algebra, and I see that the mass is going to be the density times the volume. We know the density of water is 1,000 kilograms per meter cubed, and we just found the volume. So we're going to go ahead and plug that in. And we can find the mass is going to be 60,000 kilograms. Now remember, this mass is in kilograms, but if we go back up, our specific heat uses grams. So we do need to convert that to grams. That's pretty easy, right? Because we know that 1,000 grams is 1 kilogram. So all I need to do is multiply this value by 1,000. So I'm going to take my mass, which is 60,000 kilograms, and I'm going to multiply it by 1,000 grams per kilogram. And that will give me a grand total of 6.0 times 10 to the 7 grams. You can see I put that in scientific notation because now we're getting into lots of zeros and it's just more convenient to do it that way. Great. So now I have my mass, I have my specific heat, and I have my change in temperature. We are ready to go and find Q, or the heat. So Q is going to be the mass, which remember is down here. So that is 6.0 times 10 to the 7th times the specific heat, 4.18, and now the change in temperature. It's critical that we always do the change in temperature by doing the final temperature minus the initial temperature. The final temperature is what we want the pool to be, 32 degrees C. The initial temperature is given as 16. Great. Now we can plug it into our calculator and solve, and we get 4.01 times 10 to the 9th joules. So, is this a reasonable value? Yes, I would expect quite a bit of energy needed to heat a pool, especially to double its temperature. So this definitely seems reasonable to me. All right, so that is how we find the amount of heat needed to raise the temperature of a pool. Hope you enjoyed this. I hope to see you in class, and have a great day.